In the classical realm, we take a lot of things for granted. For example, I can easily take the height of this tree and the width of this foliage. In short, shapes are easy to see and lengths are easily measured. However, in quantum scales, things are more blurry. Is this the radius or is this the radius? There isn't a clear boundary on where the particle starts and where it stops. It also doesn't help the fact that quantum particles can transition. And particles in transition also can be thought of as a superposition of multiple states. This is what's called shape coexistence. So how do we actually encode a particle structure mathematically? We can use what's called a form factor, and we can get that from experiments. It's related to the structure as it actually is just a Fourier transform of the probability density of the particle. In this study, we focus on the data of Kamimura et al. And determining the radius of the monopole transition of the alpha particle, specifically its internal conversion channel. We take the data from the experiment, aka the mass transition form factor from Kamimura, and then a form factor is curve fitted by a computer where its parameters are altered until the fit closely resembles the data. The optimal parameters after the fit are then used to compute for the transition radius, which is given by the ratio of the derivatives of the form factor. These are the results of the curve fitting of various form factors. As we can see, a lot of the fits resemble the data with R-squared values close to 1. Also, remember earlier about the Fourier transform of the probability density? I can easily take the inverse Fourier transform of the form factors I computed earlier and get the density back with this. And these are what we get. We notice that almost all densities produced are erroneous except the Wood-Saxon form factor. So, why did the curve fits yield great results while this didn't? My name is Adrian Javier, and to learn more, I invite you to my presentation about the investigation of the alpha particle transition radius in the internal conversion reaction via form factor curve fitting.